Our world. Everything we have ever known, what is it made up of? Some of you might say that we're made of matter, and you're right. To an extent, though. You see, if you said atoms, then you are actually correct. If you didn't know, not everything is made of just matter. Rather, forms of energy such as light and electricity are not made of matter. You also may or may not know that there are 5 different types of matter in the universe. One being normal, everyday matter, what you and your cells and all the world around you is made of. This makes up about 1 to 15% of our universe, or less. The second type, being dark matter, is an invisible force in the universe, pulling all objects together. This makes up around 27% of our universe. The other roughly 73% is all dark energy, in which it does the opposite, pulling the entire universe apart. There also is another type, although it's pretty much just theoretical. This is called exotic matter, which supposedly has negative mass, but that's not important right now because our topic is number 5. All of this began in 1928 when British theoretical physicist Paul Dirac predicted the existence of electrons with opposite charge, also known as positrons, through his Dirac equation, which combined quantum mechanics and special relativity. From this point to present day, physicists and researchers from all over the world kept running tests and experiments to try to prove the existence of such particles and to eventually make their own. It wasn't until 1955 that scientists started to produce their own antimatter. This process involved a machine called a particle accelerator. These things can be up to a mile long, or sometimes they go in a spiral direction instead. The way antimatter is made in these machines is very interesting. If it was a mile long, you would install electron guns on either end of this massive tube. When turned on, a singular electron on either side gets fired, and they get accelerated to the center of the pipe with electromagnets reaching near light speed. When both particles reach the center of the tube, they collide with such a high force, the energy of the collision results in the creation of an electron, and its antimatter twin, a positron. Antimatter is an extremely unstable substance because it is the opposite of matter. When a positron and an electron come in contact with each other, they absolutely destroy each other and release a tremendous amount of energy, usually in the form of gamma rays or high-energy photons. That is why this process is known as antimatter matter annihilation, and it's actually really beneficial to modern technology. You see, just a small amount of antimatter, like a few grams, can provide enough energy when destroyed to power a rocket or a spaceship. Now, as I tell you this, you might be thinking how similar this sounds to the development of nuclear energy and weapons. And you're right, because just like nuclear and atomic power, antimatter can not only be used as an energy source, but also as an extremely destructive weapon. Like I've said before, just a few grams of antimatter is very powerful. In fact, it's so powerful that just a 1 gram can create an explosion that is equivalent to the bomb dropped on Hiroshima and Nagasaki. It gets worse, just 5 grams of this stuff multiplies it exponentially to 210 kilotons of TNT, 10 times the bomb dropped on Japan, to put into perspective. Oh, and a fun fact, in 2032, there is a less than 2% chance of an asteroid hitting the Earth, which would have the impact energy of 7.8 megatons of TNT, or 7.8 million tons. This is equivalent to 520 times the atomic bomb from Japan. So yeah, take joy in that wonderful fact, very, very massive explosion. How fun! Aren't you just so excited?